Hey there, in this video we're going to continue using the law of logarithms to expand. So we want to expand this expression, the log base 2 of this quantity. So we're going to use our laws, which are these, the product, the quotient, and the power rules of logarithms. So for the first one, let's see. So the big thing that sticks out to me is the division. So the quotient one. So that means that, notice that inside the single logarithm, we have a division. So just like here, inside a single logarithm, we have a division that produces the subtraction of two different log quantities. So that means I can write this as log base 2 of the numerator, x to the fifth, minus then log base 2 of the denominator. And the denominator is the square root of x plus 1, so I'm going to write it as x plus 1 to the 1/2. Any radical, we want to write it with the rational exponent, so that then we can use law number 3, where we can bring the power to the front. So now let's see, I don't see any multiplications, divisions, or the only thing I see is powers. So that means I can use number 3, where we bring the power to the front of the logarithm that it belongs. So the 5 is going to come to the front of the log base 2 of the x, and the 1/2 is going to come to the front of the log base 2 that has the x plus 1. So this will look like 5 log base 2 of x minus 1/2 log base 2 of quantity x plus 1. And so, looking back at our rules of logarithms or laws, we have, notice that when I have a single logarithm, I have product, division, so quotient, and I have something to a power. So if I'm going to use any more laws, I need to figure out, do I have any multiplication, division, or exponents? So here, right, I had division, and here we had exponents. So now I have log base 2 of just x, so there's no more multiplication, division, or exponent here. Now in the second expression, I have log base 2 of x plus 1. This is a plus, but there's no multiplication, division, or exponent, so we're done. So notice that so my caution here will be there is no rule, right? If I have log base a of a plus b, there's no rule that gives me anything. So this is not equal to log base a of a plus log base a of b. So the logarithm is not distributed. So this does not distribute. So there's nothing I can do to this x plus 1. I can't expand it. Notice that my addition rule is that if I have two logs being added, then I can combine it into a single log, but not if I have inside, so the argument inside the log, I can't expand that anymore. So this is as far as we can go. Now, as I mentioned in my last video, these rules go back and forth. So I can go from a single logarithm to an expansion, but I can also go from an expanded logarithm expression to a single log. So that's what we're going to do for the next example. So we're going to combine into a single logarithm. And this is really helpful when we're using laws of logarithms to solve equations. So for my first one, we're going to say I have 3 log base 5 of x plus 1/2 log base 5 of x minus 1. So my log has to be the same base, minus 4 log base 5 of x plus 2. And we want to combine this into a single logarithm. So looking back at our rules, so we're doing them backwards. So the first thing to look for when combining into a single logarithm is any coefficients. So the 3, the 1/2, and the 4, we can turn into exponents. So we're going to do that part first. So this is going to become then the log base 5 of x to the 3rd power. So that coefficient becomes an exponent to the x plus log base 5 of, now this is a quantity x minus 1, so the x minus 1 to the 1/2 power. So this coefficient becomes an exponent minus log base 5 of x plus 2 to the 4th power. So the coefficients become the exponents. And so now, following the order of operations, we still go from left to right. Sort of like following the order of operations, I should say. So we still go from left to right. So these two logarithms, so we've got to take two at a time. There's a plus in between. So the law of logarithms says if I have the sum of two logs, I can combine them into a single logarithm by multiplying the inside. So that's what we're going to do here. So the base is log base 5. So I'm going to have the log base 5 of the product of the insides. So I'm going to have then x cubed times x minus 1 to the 1/2. At this point, if you want, you can turn the 1/2 into a square root. I'm just going to leave it like this. So I'm going to have log base 5 of x plus 2 to the 4th. And notice again, I have two logs, log base 5 of something minus log base 5 of something else. So I have two log quantities with a minus in between. So that means I can turn this subtraction of two logarithms into a single logarithm by dividing the a and the b, dividing the insides. So then this one is going to be the log base 5, and I'm going to divide the insides. So I'm going to have x cubed times the square root of x minus 1, right? 1/2 becomes a radical with the index of 2, so square root over the inside of this log. So this will be the x plus 2 to the 4th power. And so now I have written the whole expression into a single logarithm. So that's how we go from a complex logarithm to a single logarithm. So let's try another one. My next example, what if I have 3 natural log of x plus 1/2 times the natural log of y minus 2/3 natural log of x plus 5. So remember, we're trying to write it into a single logarithm. So the first thing here will be, well, let's distribute this coefficient, this 1/2, because we have things kind of trapped in this parentheses. So the first quantity stays as it is, and I'm going to distribute that 1/2. So 1/2 natural log of y. Notice that 1/2 is a coefficient, so I'm going to multiply it by the invisible 1 that sits in front of the ln of y, minus 1/2 times 2/3. So the 2's cancel, so I get just negative 1/3 natural log of x plus 5. And now it looks like the previous one. So again, I'm going to take two log quantities at a time. Oh wait, I can't do this, right? I can't combine them just yet because I have coefficients. So I kind of went against my own rules. You have to look for the coefficients first. So let's fix that. So this is going to be then the natural log of x cubed, right? The 3 becomes an exponent to the x, plus natural log of y to the 1/2. The 1/2 becomes an exponent to the y, minus the natural log of x plus 5 to the 1/3. The coefficient of 1/3 becomes an exponent to the x plus 5. And now I can say, okay, I have a log and I have two log quantities, always take two at a time. And because they're separated by a plus, that means I can combine them by multiplying. So this will be the natural log of x cubed times y to the 1/2, minus the natural log of x plus 5 to the 1/3. And now, again, with two log quantities, I can say, okay, they're being separated by a minus, so I'm going to use the minus subtraction to quotient. So this becomes the natural log of x cubed square root of y over the cube root, since it's 1/3 of x plus 5. And that's it. We combine 3 logarithms into a single logarithm using the rules of logs.